Hi again, guys. So hopefully you've watched that little introduction of explaining what phase angle is, how it affects the graphs. It's similar to the quadratic graphs. It shifts the horizontal direction, left or right. It's always the opposite of what you think. So if it's a negative number in the bracket, you would think it would go left, as in taken away, but it actually moves it right. And if it's a positive number in the bracket, as in the phase angle is a positive number, it actually moves the whole thing left. So what we have to do at National 5 level is we are given the graph. We don't have to draw any of these at National 5, but we are given the graph that has been affected, and we basically have to understand how is it being affected, what are the values of A and B. So we have to have a reference point in our head as what is the standard graph look like? Where are the points in our standard graph? So the first one is sine. Where would sine graph usually start if we're in the range of 0 to 360? Where would the maximum usually be? Where would the minimum usually be in terms of the x direction, in terms of the left or right? Because that's going to tell us how much the graph's been affected left or right. Okay, and then what we also have to do is you can see that A is the amplitude, so therefore the graph has actually been stretched as well. Now that's fairly obvious, hopefully, to get the amplitude, because our maximum is at 2 and our minimum is at -2, so that's a distance of 4. Now remember, the amplitude is always half of that distance between the top and the bottom, so therefore the amplitude is half of 4, so that's going to be an answer of 2. Now, how has the graph been affected left or right? Well, our normal sine curve would start at 0. Now we can see it starting here. I don't have a number for that, so I could guess roughly what it is, but I don't know exactly. In this case, the whole key is this coordinate point I'm given up at the top. Okay, I'm given that coordinate, which is the maximum point of this graph, and it's telling me it's at an x direction of 120. Now I should know from my standard sine curve, if I just draw onto this, that my standard curve starts at 0, standard sine curve, and it would go up to a maximum of 2. If it's 2 sine, it would go up to a maximum of 2 and it would come back to 180, come back to 0 at 180 degrees in the x direction. So if normally the maximum would be at an x direction of 90, and now it's at an x direction of 120, the graph has been shifted 30 degrees to the right. So I can mark that on, that it's been shifted 30 degrees to the right. Now, here's the confusing bit, because remember, if it's a minus in the bracket, it means it gets shifted to the right. So it's not plus 30, it's actually x minus 30. Okay, and the way you can think about that is if you have you look at your red graph here, you can think, what would I need to do to get back to where the graph should be, in inverted commas? So the graph's maximum of 2 sine x should be at 90. It's actually at 120, so it must be minus 30 in the bracket to get back to 90. So B has a value of 30 degrees, which means if we write down the equation, it's y equals 2 sine, and I need x minus 30 to get back to 90. Okay, wee bit more confusing when we're working with phase angle. I hope that made sense. We'll do another one just now, and hopefully it will make sense again. Now, the confusing bit is that you may have noticed that if you move the sine curve by 90 degrees, it actually turns into the cosine curve. So it's hard to, this curve kind of just looks exactly the same as the sine curve, really, doesn't it? Looks almost identical to the one that we've just done, but it's actually a cosine curve. So that means the starting point should be different, and those x values of those kind of minimum values, maximum values, they should be for the cosine curve this time. Okay, initially though, it's probably easiest just to get A out the way. A is always half the distance between the maximum and the minimum. So the maximum is at 4, the minimum is at -4. That's a distance of 8. So A is half of 8. So A is 4. Now we're on to the trickier bit, which is understanding how the graph has been shifted left or right. So if we have, and again, we can look at the first page of our notes to have the standard sine graph as a reference point. Okay, what we're focusing on here are these two numbers. We've got a point here that's given to us as 290 degrees, and we know 4 is the maximum height. And we have another point that we could use here, which is this 20. That's telling us the graph cuts the y-axis at 20. Now what I'm going to do is I'm going to mark on the standard graph, which would be 4 cosine of x. It would start at a maximum of 4. It would come down at 90. It would turn at 180. It would come back through at 270, and it would finish up at its maximum at 360. That would be 4 cosine x. Can maybe mark that on. Should have marked on that other one probably that is 2 sine x. So we can use that standard cosine graph to tell us how much has it been moved left or right. So hopefully you see that the normal cosine curve should be cutting the x-axis at 90 degrees. It's actually cutting the x-axis at 20 degrees, so it's been shifted left by 70 degrees. Okay, so think about it as the one that's been changed, the one that's been shifted. What would I need to do to get back to where it should be? I would have to add on 70 degrees. So if it's x plus b, that means that it's got to be x plus 70 degrees. And therefore my equation should be y equals 4 cosine, and it's x plus 70 degrees. And we can kind of confirm that as well with this this maximum. This maximum in my affected graph is 290. Now we've said in our 4 cosine graph the maximum should finish at 360. So if I add 70 to 290, I get to 360, which is where the cosine graph should finish. So we've used both points to kind of prove it's right. Okay, so we've got y equals 4 cosine x plus 70 there. Okay, I kind of laboured the point a bit with those ones. Kind of move slightly quicker through these 2 past paper questions that you should be able to make a good stab at now. So what I'd like you to do is actually, if the teacher could pause the video for 3-4 minutes and allow the pupils to just have a go at these 2 questions. So I'll just read through them. So part of the graph of y equals a sine x plus b is shown. What are the values of a and b? A is half the distance between the maximum and minimum. That should take 2 seconds. B is however the graph has been affected left or right. So the information we're given here is this 210 degrees. That's the important information. So think about where would that normal sine graph come back to the x-axis. So how has it been affected? Okay, so have a go at that. And then the second one is actually you're given the equation. It's 3 cosine x plus 45. And you're asked what is the coordinates of this minimum turning point. So think about where the cosine curve this time would usually have its minimum. What would the x value be when it's down at its minimum? What would that minimum now be if it's x plus 45? And then what would the value of the y be? Okay, so if the teacher could pause this video just now and just give pupils 3-4 minutes to have a go at these, and then I'll talk about the solution. Okay, hopefully you are all just about done this. So I always like starting with figuring out what the amplitude is first. It's the easiest one. It's half of the distance between 4 and minus 4. So the value of 8 is just going to be half of 8, which is 4. Now the normal sine graph, you're more than welcome to just draw the normal sine curve onto your diagram here. I like to do that. So the normal sine curve would start at 0. It wouldn't start along here. It would start at 0. So the graph has been shifted to the right a little bit. So it would start at 0, it would go up to 4. Now it would come down at 180. And it would come down here and it would finish there. So what's happened to the graph? The graph has been shifted 30 degrees to the right. So how would I get it back to where it should be? I would have to subtract 30 degrees. So actually in that bracket, it needs to be x minus 30. So if it's x plus b, that means b has to be a negative 30 then. So either write the values of a and b, or you could just write, if you wanted to, you can just write down what the formula should be. So it should be 4 sine of x minus 30 degrees. Okay, so just be careful. Sometimes it'll be a negative in that bracket they give you. Sometimes it'll be positive. You need to understand what that should be. The second one, well, we know the maximum and the minimum is 3, so because it's 3 cosine. So straight away, I actually know the y value is a minus 3, because I know that the maximum it goes up to is 3, the minimum it goes down to is minus 3. So it's all about trying to figure out what the x direction of this minimum turning point would be. Now again, if I can think about my normal, cosine curve, that would start up at 3, it would be 90 as it goes through the x-axis, and it would come down at 180, and it would go back up, blah, blah, blah. So plus 45 means we can see clearly that it's moved to the left by 45 degrees. Okay, so we're not trying to figure out what the equation is this time. All we literally need to do is take away 45 degrees from 180. So we know that it's minus 3 for the y direction. 180, move 45 degrees towards 0, so that's just 135 degrees. You don't actually need the degrees in there. So 135 minus 3 would be the coordinate of that turning point. Okay guys, so what I'd like you to do now please is practice by yourself. So this starts, the phase angle questions start, this is the Unit 3 booklet of course. This is on page, it is on page 31 and it's question 4 that I want you to start on. Now if you have a look at, I've taken a snapshot of it, it's quite confusing because the numbers that they've written onto the graph aren't the kind of standard 90, 180, 270. It's the graph, the numbers after they've moved either left or right. So you have to first of all understand if it's cosine or sine. So the first one, I hope you'll agree, is the sine curve, and it's just been moved a wee bit left. So it would usually come down at 180 here. It's actually coming down at 170, so it's been moved 10 degrees to the left. So that would be like sine moved 10 degrees to the left, so that's x plus 10. So that would be the graph of y equals sine x plus 10. This one is again sine graph, but moved to the right hand side. So it's sine, it's moved right by 40 degrees. So it would be x minus 40. Okay, so I won't know to tell them all obviously, but pick out what sine and cosine are. If it's sine or cosine, how much has it moved? Where should those values be? It really does test your understanding of those fundamental properties of the sine and cosine curves, and then write down the equation. Now, if you move on to question 5, it's just a bit more challenging in the fact that it involves tan, which is always just a bit more challenging, and the amplitude is affected. So it's not just a 1 sine or a 1 cosine. It's going to be you're just going to have to work out the amplitude as well. Okay, and if you really get through that quickly, then you can try and draw some of these for yourself, which is quite challenging. So again, you're focusing on what is the shape of the curve, and then putting the numbers onto the diagram after you've drawn the shape rather than before. So similar to kind of how they look in question 4 and 5. Okay, hope you got on okay with that, guys.